Hello students, today again I will explain another video of class 10 science set number 5, that is periodic classification of element. In today's video I will explain about the characteristics of periods and the group. Right, before I start explaining this video, please take out your notebook, pen, pencil to copy down the important topics. Without wasting the time, today I will start explaining about the characteristics of the period and the group, okay, of the modern periodic table. Right, look here, characteristic. The first one, characteristics of elements in period. Right, now characteristics of the element in periods. Okay, the first one I will explain. Look here, the first part is about the valence electron. We all know about the valence electron, right? What is meant by valence electron? I already explained. The valence electron means the number of electrons which are present in the outermost shell, right? That is, again I will explain about this. Definition is the number of electrons, the number of electrons present in outermost shell of an element. In here, the valence electron is defined as the number of electrons present in outermost shell of an element. Right. So now I will write the one of the series. Now the third period. Now we are considering the elements in the third period. Say the third period. Look here. In third period, the elements are now sodium. Right. Next, magnesium. Next, aluminium. Next, silicon. Next, phosphorus. Next, sulfur. Next, chlorine, and last one is the argon. These are the elements which are present in the third period of the modern periodic table. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Right. Now the valence electron of sodium is 281. Right. This is the valence electron. Okay. In magnesium is 282. So aluminium is 283. Okay. Now silicon is 284. Phosphorus is 285. Right. Sulfur is 286. Chlorine is 287. And argon is 288. Now look here. In sodium, the valence electron is first one is 1. Okay. Magnesium 2. Silicon 3. Okay. Aluminum 3. Silicon 4. Phosphorus 5. Sulfur 6. Chlorine 7. And argon 8. Right. That means that, now look here, in the valence electron, in the valence electron, what will happen? On moving, okay, from, okay, left to right of, on moving from left to right, okay, in a modern periodic table, in a period of modern periodic table, what happened? The valence electrons of the element, okay, valence of electron of the element increases from 1 to 8. Right. The first one is sodium is 1 and argon is the 8. Right. That means the valence electron of the element increases from 1 to 8. This is the part about the valence electron, okay, for this characteristics of element in a period. Right. Just copy down this one. Okay, done. Okay. Now next one is the number 2 is the valency. Number 2 is the valency. Valency. Now number 2 is the valency. Look here, same thing in sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. Right, look here. The valency of the sodium is what? Magnesium 2, aluminium 3, silicon 4, phosphorus 3, sulfur 2, chlorine 1 and 0. That means that the valency of the elements, right, on going from left to right, okay, in a period of the modern periodic table, the valency of the element first increase from 1 to 4, then decrease to 0, right? In here, same thing in here you can write on moving, okay, from left to right in a period, the valency of the elements first increase from 1 to 4, then decreases to 0. Right, the first one is the 1 and the last one is the 0 and the middle one, the highest one is the 4. Right, that means what? The one going from left to right in a period, the valency of the element first increases, then decreases to the 0. Okay. The number 3 is what? The number 3 is known as the size of the atom. Size of atom. Now, size of atom, look here. Sodium will be the, in these portions, okay, we can remove this argon because in here, argon we are not considered. Right. Look here, the size of atom I will explain in here. Okay, in sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine. Now look here, the size of the atom in this one sodium is 186, okay, picometer. Next is the magnesium is 180, right. Next aluminium is 118 and in silicon is 110. Silicon is 100 here aluminium is 143, silicon is 118, phosphorus is 110 and sulfur is 104 and chlorine is 99. That means that sodium has more this what size than the others, right? That means the least one is the chlorine. That you can write like this on moving from left to right in a period, the size of the element, the size of the element decreases, right? That sodium has a more this was size, right? That's more bigger. Next is the magnesium, next aluminium, silicon, phosphorus, sulfur and chlorine is the has this smallest, okay, size, right? This is about the size of the atom. Please copy down. Done. Okay. Next, number 4 is metallic character. Metallic character. Now look here. sodium, next magnesium, next aluminium, next silicon, next phosphorus, next sulfur, next chlorine. Right, look here, in here, this is the highly reactive element. Right, this is the highly reactive materials. Now these are highly reactive materials, and this is what metalloid, and this is what non-metal. Look here, this is the metals, this is what metalloid, this is the non-metals. Look here, this metal, this sodium is more active than the magnesium, than the aluminum, right? And this chlorine has more active than the sulfur. Okay, this point you keep in your mind, right? Now look here, on moving from left to right, on moving from the left to right in a period, on moving left to right in a period, the metallic characters of the elements decreases, but the non-metallic characters of the element increases. Okay, but the metallic character will be decreased, but the non-metallic character will be increased. Right, this is the one. And the most important in here, okay, this is not in your syllabus, but you need to learn about this part. There is electronegativity. Electronegativity means what? Electronegativity is the what? It is the power of the element to receive extra electrons from the surrounding to form negative charge. Right, that electronegativity is nothing, that is the power of the elements or the atom which can receive the extra electrons from the surrounding to form the negative charge. Right, that is, we already know that all the non-metal, they can easily receive the extra electron and to form the what? Negative charge. Right, that is why these non-metals have the highest electronegativity than the what? Metals. Now the most important point is, on moving from left to right in a period, the electronegativity of the element increases. Why I am writing this one? Electronegativity of the element increases. Why? Because we already know that the metallic characters of the element decrease, but the non-metallic character will be increased. Right? Due to the increases of the properties of the non-metallic characters from moving from left to right, we can say that the electronegativity of the element will also increases. Okay, on moving from left to right of the in a period of the modern periodic table. Right, this is the important part. Okay, please copy down. Then next, Next is the chemical reactivity. Now number 5 is the chemical reactivity. Now look here, sodium is more reactive than the magnesium than the aluminum, right? Look here, it is more reactive than the silicon, right? And look here, next is the phosphorus, right? Phosphorus is non-metal, then this chlorine is more reactive than the sulfur is more reactive than the what? Phosphorus, and chlorine is more reactive than the sulfur, right? Look here, on moving from left to right of right in a period, what happened? The chemical reactivity of the element first decreases, but first decreases, then the chemical reactivity of the element first decreases, then what? Increases, and then increases, and then increases, right? This is the percent, okay? Now the metallic character first decrease, right? And then what happened? Then the metallic character will be increased. That means the chemical reactivity will be increased, okay? These are the high reactive. This is the highly reactive metal, and this is the highly reactive non-metal, right? Next, number 6 part. Number 6 part is the nature of oxide. This is the last part, okay, of this period. Nature of oxide. We all know that all the metals form what? Base, right? That is basic oxide, okay? And all the non-metals form what? Acid, okay? Now look here, on moving from left to right in a period, the basic nature of the oxide, okay, first the basic nature of the oxide, okay, decreases, but acid nature of the oxide increases. We all know that all the metals, they can form the basic oxide, right? What about this one? This non-metal, the non-metals can form the acidic oxide, right? That's why the basic nature of the oxide will first decrease, okay, but the acid nature of the oxide will increase, okay? This is the nature of the oxide, okay? Please copy down. Done? Okay. Can I remove? Yes. Next is for the characteristics of the elements in group. Next is the characteristics of elements in groups. The first one about is valence electron. Valence electron. Say in group number 1, look here, I will write group number 1. Ha, li, na, ka. Okay, we can write a Ripsi-Fra also. Ripsi-Fra. Okay, Ripsi-Fra. That is hydrogen, lithium, sodium, potassium, rubidium, cerium, and francium. Okay, they are all valence electron 1. Right? Why? Because all the elements, they have the same valence electrons. Okay, there is one valence electron. Because of this, they are put in the group number 1. We already studied in the previous session. Right? That is what. The first part, one is the what? All the elements of the group. All the elements of the same group have similar valence electron. Right? They have the similar valence electron. Okay? Next, number 2, valency. We all know that if the valence electron is similar, then the valency will also similar. Right? Look here, in here also, all the elements, okay, in the same group have similar valency. If the valency is similar, then what happens? That is, I will write in here similar chemical properties. Look here, the chemical properties of the elements depends on the valency. That's why, if the valency is similar, then the valence this what chemical properties will also similar. Okay, number 3, metallic character. Okay, on going down the group, metallic character of the element increases, but non-metallic character will what? Decrease. Metallic character, okay, increases, but the non-metallic character decreases. Okay, metallic characters of the element decreases. Okay, look here, in here the metallic character. For example, look here, the sodium is the non-metal, lithium is the little less reactive. That is, sodium is more reactive than the lithium, potassium more reactive than the sodium, rubidium is more reactive than potassium, cerium is more reactive than the rubidium, and francium is more reactive than the cerium. Okay, that's because this down part, they are all the radioactive elements, right? Okay, and in here also, can I write this first part? Okay, now look here, if the non-metallic character is increases on going down the group, look here, electronegativity. In terms of electronegativity, in here on moving down the group, okay, the electronegativity of the elements decreases. Why? Obviously, the non-metallic character will decrease. That means the electronegativity will be decreases on moving down the group. Right? Copy down this one. Done? Okay. Next is what? Chemical reactivity. Next is the number 5, chemical reactivity. On moving down the graph, the chemical reactivity of the elements increases. We all know that this francium, the last part, the bottom part of the elements which are present in the modern periodic table, they are radioactive elements. Okay, they are highly reactive elements, right? That is why on moving down the group, okay, the chemical reactivity of the element increases, right? The last part, that is what nature of the oxide. Nature of the oxide. Look here. On moving down the group, on moving down the group, the metallic character increases, right? That is, on moving down the group, basic nature of oxide increases, okay, but acidic nature of oxide decreases. We all know that the metallic character is, okay, metallic character of the element will increase on moving down the group. Because of that, what will happen on moving down the group, the basic nature of the oxide will be increased. Why? All the metals, they have this one form, basic nature of oxide, right? Because of that, on moving down the group, the basic nature of the oxide will increase. But opposite to them, that is, non-metallic character will be decreased, right? That means that what happened on moving down the group, the non-metallic character will be decreased. That means the acidic nature of the oxide will decrease. That means all the non-metal, they form what? Acidic nature of the oxide, right? Because of that, we are writing like this: on moving up down the group, basic nature of the oxide increases, but the acidic nature of the oxide will be decreased. Okay, these are the characteristics of the pH and group. Okay, that means characteristics of the element which are present in the pH and in the group. Okay, and please watch this video carefully. If you have any doubt or any confusion, let me know. Okay, I will please send one message to the WhatsApp group. I will clear your doubt, right? And please copy all these things, okay, without any mistake, right? Thank you and have a nice day. Bye bye.